Hi, everyone. This is Isaac Sanchez, and this is one of a two-part podcast series in which we discuss when to use Silicon Labs oscillators. Joining me today is David McParland, product manager for our oscillator portfolio. Hi, David. Thanks for joining us today. How are you doing today?
Doing good. How are you doing?
I'm pretty good. So, we recently just had a few new parts added to the oscillator product matrix, and I had a few questions for you to see if you can help me refresh my memory on how best to support this product line. Right off the bat, I was just kind of wondering, when is it appropriate to use a XO and buffer architecture versus a clock generator?
Okay, it's a good question. We get this answer. We get this a lot, and the answer is it depends. When you can, it's usually advantageous to try and consolidate as many clocks as you can into one chip. You get improved and optimized jitter performance, lower power consumption, obviously fewer components, PCB area savings, lower bill of material costs when you can consolidate up everything into one clock generator. But you can't always do that. And sometimes this choice really depends on the number of clocks that are needed. So if a design only needs one or two clocks, then an oscillator plus buffer or two oscillators is probably going to be the right choice. But if the design needs three or more clocks going to one device, say an ASIC or an FPGA, then a clock generator is typically going to be preferred here. It also depends on how many different or unique frequencies are needed. If a design needs just say 10 copies of the exact same frequency, then an oscillator with a buffer is going to be the best solution from a cost standpoint because a buffer is going to be less than a clock generator. But if the design needs a bunch of different frequencies that are all different, then a clock generator is going to be best suited for this because it can provide multiple different clocks all from one device. It also depends on board architecture. So if you have a large board with multiple chipsets, that all need to be driven by clocks, customers often just prefer to put the oscillator or an oscillator or buffer right next to those chips that need to be clocked. This is done as opposed to a clock generator on a large board that then has to have traces routed across the whole board. So again, on a large board, customers often want to put the oscillator buffers next to the individual components to minimize jitter that can get picked up from long PCB traces. This can also help for EMI concerns. Again, if you have shorter traces, then you don't have as much stuff potentially radiating out. And often you may have a system design where you have boards that are connected over a backplane. And so in those situations, it's just not practical to have one clock generator on one board, clocking a chip on a different board. And so individual oscillators or local oscillators and buffers will make the most sense there. And in spite of all of this, sometimes there are situations where a clock generator may actually make the most design sense, but sometimes customers still prefer to use multiple oscillators and buffers scattered across the board, either because of historical reasons. In other words, it's just the way they've always done it, or that's the way the company has always done it, or for supply chain concerns. Sometimes it's easier. Companies sometimes prefer oscillator buffer architectures because it's easier to find second or third sources for oscillators, whereas custom clock generators that consolidate everything into one chip are usually sole sourced, and so sometimes companies have reservations for that. But the good thing is that Silicon Labs has such a large portfolio that we can support any preferred architecture, whether it's all consolidated into one clock generator, oscillators only, or oscillators plus buffers. I've sat in many customer meetings where one designer only wants to use oscillators and buffers, and the designer sitting right next to him only wants to use clock generators on a different design, and we can help both. So it's not a simple answer, but hopefully that helps help a little bit.
Yeah, definitely. I think that was a lot of useful information, especially there at the end where we're flexible for both types of design engineers. When asking those engineers those questions, mainly, I guess let's talk about the one who wants to use the oscillator. How can we help that design engineer narrow down which oscillator would be right for their design when showing them our product matrix?
Okay, good question. Yeah, so the most important parameter for oscillators is the jitter performance that they need. And I've broken down that portfolio slide by into the different families based off of the typical jitter requirements. And the reason that that's important is because that largely drives cost. And when you can find out what a customer's jitter requirement is, that also helps you better understand what kind of application this may be, what kind of, is it going to, a higher performance board is going to need much lower jitter. And, we want to make sure that we're not recommending a part that's overkill for say a consumer application that, is fine with a picosecond. And on the other hand, we don't want to, recommend a part that isn't up to, less than 200 femtosecond device, say that our new Ultra Series oscillators need. So understanding the jitter requirement is the first place to start. Also, we need to know the specific frequency. Some of our families support more, so our consumer devices, our 51X parts, don't go as high in frequency, whereas our higher performance parts go much higher. And so again, that's going to be application dependent, but that'll also help steer you into a specific recommended oscillator that's needed. Another important question to ask is whether or not their frequencies need to change, either in the design, like either the design requires it itself, or whether they may want to change the frequencies at some point later just because they aren't exactly sure yet. And the reason for that is because most competitor oscillator vendors, they only have single fixed frequency oscillators. The part boots up and it comes out with that one frequency. But we have some additional capabilities with dual, quad, and I2C programmable parts. And this is kind of a unique capability that our parts have. And if customers need I2C programmability, obviously, that helps drive what specific I2C device they need. But sometimes if they don't know if they're not sure if I need 100 megahertz or 125 megahertz, we could suggest the dual part where they can get both of those frequencies pre-programmed into the device, and it just makes it easier for them to use. So basically understanding what their exact frequency requirements are and whether those might change in the future will help. Another important parameter is stability. This is essentially how accurate is the oscillator over temperature range. All of our parts are spec'd over minus 40 to 85 C, but we have various stability options where customers who require very tight stabilities as low as 7 parts per million over temperature, we have those options as well. And then finally is package size. Oscillators there are a handful of very set industry specific footprints. And fortunately, with a lot of our new oscillators that we just launched, we have more package sizes now. Previously, there were some cases where a customer needed a certain package size. Everything else would have been great, but we just didn't have it, and we couldn't support those designs. Now we can. So those are some of the key parameters to flesh out from customers when you're talking with them.
You've mentioned, our recent updates multiple times throughout this podcast. Well, we recently updated our oscillator product family. How do these additions make us more competitive?
Okay, so our newest parts are 54X Ultra Series devices. These are industry-leading ultra-low jitter, only 80 femtoseconds. So as timing requirements have gotten tighter and tighter, the jitter requirements have gotten tighter. It used to be 500 femtoseconds was acceptable for high performance. Now it's becoming 200 femtoseconds, 150 femtoseconds max requirements. So our new parts, the 54X Ultra Series family, can meet these really tight new requirements with room to spare. So that makes us more competitive in the high-end space. These parts also have, again, single, dual, quad, and I2C programmability, so the same kinds of feature sets that our older legacy devices have. And we have customers who need all of those variants. And then the new additions that we just launched for our older parts are our 51X and our 59X parts. Basically what we did is we added 2 package sizes smaller for this. And I also forgot on the 54X family, we also have one larger package size, a 5x7. And so again, having a ton of new package sizes, in addition to expanding the portfolio up in performance and these new package sizes on some of our older parts, overall, it helps us have a much bigger portfolio. It helps make us more of a one-stop shop And again, it just helps us make timing easy for the customers. They can come to one place and they know that they're going to be able to get a device that they need.
Thanks for the great information, David. In part 2 of this series, we will discuss oscillator advantages that you need to know.